Merge sorted array. You're given two integer arrays, nums1 and nums2, sorted in non-decreasing order, and two integers, m and n, representing the number of elements in nums1 and nums2, respectively. Merge nums1 and nums2 into a single array sorted in non-decreasing order. The final sorted array should not be returned by the function, but instead be stored inside the array nums1. To accommodate this, nums1 has a length of m plus n, where the first m element denotes that the element should be merged, and the last n elements are set to 0 and should be ignored. Nums has a length of n. So now, what should our goal should be to return the final sorted array should not be returned by the function, but should be stored inside. So let's copy this so that we can keep this in mind. To denote this, to accommodate this, let's copy this too. And that's it. We're done with the copying, I think. Okay, so now we have this example. We have this list over here, and so from here to here, this is our list. These should be ignored. Our m is 3, where it ends. I mean, how much the number of elements. So 1, 2, 3. These should be ignored. Nums, we have this 3. We have 3 here as n. And they were merged. And this is what we get after they were merged. So in this one, this and this, we have 1. There's none here, so we just have 1. And here, nums1 has 0, nums2 has 1, and they were merged, and we have these. So this is a simple problem that we can easily solve with a heap merge function. So let's make our variable merged equals to a list. Let's make a list and then merge it. heapq.merge, and then nums1, 2 all the way to m. That's how much we have in this, how much elements we have in this. And then let's get out of this, and then merge nums1 all the elements to m to now nums2. So now let's so that's it. This will use the heap the merge function to efficiently merge this, and and now this we have to sort our final array, not return it, but just store it inside the nums1. nums1 is now equals to merged. and let's run it and see if it works. And it's been accepted successfully. And our time and space complexity time and space complexity, I'll just do time complexity first. Time complexity is O of m plus n. Each element in each list is processed once by our heapq.merge function. Our space complexity is also O of m plus n. Each element in the size of the space grows proportionally to the proportionally to and this one's not sound right. In proportion, oops, I said grows in proportion to the size of each array. That's how you get to the element in proportion to the elements of each array. And that's it. So let's submit it to see if it will pass all cases. And that's it. So our time complexity is, well, efficient, but our space complexity does need to take space. But this is a simple way to be able to solve this problem that you can also use the heap.merge method if you're stuck on something. And that's it for this problem.